Sure.
Today, I have the pleasure of interviewing Dr. Jonathan Little, a professor at the University of British Columbia in the School of Health and Exercise Sciences. And I'm very excited to talk to you today because you have some fascinating research. You're constantly publishing research that I am personally super interested in because you look at different interventions when it comes to diet and exercise in the context of metabolically compromised individuals, largely type 2 diabetics and even pre-diabetics. So if you want to just introduce yourself and give a brief overview of your research at UBC.
Sure. Yeah. Thanks for that intro, and it's great to be here. I'm happy to be on the podcast. And I guess if I try to sum it up, our lab we try to optimize diet and exercise interventions for the treatment, prevention, and now remission of type 2 diabetes. So that ranges from some more mechanistic, well-controlled lab studies where exercise or diets, all the way up to clinical trials in patients with type 2 diabetes.
Cool. And you've been interested in this since your graduate work. So you've been working in the type 2 diabetes world for a long time. And I think you started out looking at exercise interventions and most notably high intensity interval training. Do you want to give an overview of that research and how you kind of got interested in that?
Yeah, sure. So I did my PhD with Marty Gabalis, and we were studying mitochondrial adaptations to high intensity interval training. So we were looking at things like gene expression of PGC1 alpha and activation of AMPK in response to interval training versus other types of exercise. And at the time, one of the prevailing theories or the underlying mechanisms around the development of type 2 diabetes was that skeletal muscle mitochondrial insufficiency or dysfunction would lead to an accumulation of intramuscular lipids that would drive muscle insulin resistance and lead to the development of type 2 diabetes. So there was a lot of interest at the time in mitochondrial therapies and how to improve muscle mitochondrial function. And we were showing in multiple series of studies, that HIIT and even sprint interval training was a potent stimulus to increase mitochondrial content in muscle. So we kind of put two and two together and said, well, if low mitochondrial content or capacity is driving the development of insulin resistance in type 2 diabetes, and HIIT is able to really potently increase mitochondrial content in muscle, why don't we try this as a therapy in type 2 diabetes? And both Marty and I had not run a clinical research study, but he kind of gave me the green light to do this as my final PhD study. So we recruited a small group, a pilot study of patients with type 2 diabetes, and we did the first ever HIIT in type 2 diabetes study, I think, and showed that it not only increased their mitochondrial content in muscle, but also improved their glucose control, which we measured in that study with continuous glucose monitoring. So that was kind of my first foray into type 2 diabetes. Now I think that the accumulation of intramuscular lipids is still important and involved, but probably not the causative factor in the development of type 2 diabetes. And we've moved on from studying muscle now to looking at inflammation and beta cell function and other aspects of type 2 diabetes pathophysiology.
There's a lot to unpack in that. In my head, I'm just picturing like muscle being the organ that might be deteriorating, like the insulin sensitivity at the level of our skeletal muscle. If that is being reduced first, is that like the first sign of insulin resistance or type 2 diabetes?
Yeah, so it's interesting. It's obviously hard in humans to tease this out, but the prevailing theory at the time, and you'll still see it referenced a lot, is that from Ralph DeFronzo's excellent work, skeletal muscle insulin resistance is the primary defect in type 2 diabetes. But that's really been demonstrated in their studies, was cross-sectional studies, right, where they took healthy, lean individuals, individuals with obesity that were insulin sensitive, individuals with obesity that had insulin resistance and type 2 diabetes, and they kind of showed a stepwise graph of muscle insulin sensitivity. But that's obviously not causation in that. And the other fact or stat that always gets thrown around is, muscle's responsible for 80% of glucose uptake, right? And again, that's a bit misleading because that's from studies that infuse glucose, not ingest glucose. So it's not a perfect matchup. So I'm not trying to say muscle's not important, and my a lot of my muscle colleagues probably will cringe, but I don't think muscle's the primary or the most important organ in the development of type 2 diabetes, as well as now in the work we're doing on remission of type 2 diabetes. I think the liver and the pancreas are more important in that than muscle. So muscles plays an important role, obviously, but I don't think it's the primary or the number one organ or tissue that's driving the disease, or that we need to target to reverse the disease.
Could you unpack a little about the liver? Like what is it about the liver that?
Sure. Yeah. So we know that fasting glucose, which is high fasting glucose, so you wake up in the morning with high fasting glucose, that's primarily driven by your liver releasing or leaking too much glucose out through both glycogen breakdown, but largely gluconeogenesis. So you're kind of baseline how we typically diagnose or would look at type 2 diabetes is driven by the liver producing too much glucose. And then even postprandial hyperglycemia, so after you consume some carbohydrates and glucose spikes, that's primarily an inability of shutting off your liver. So I think that the liver plays a bit more of an important role than muscle in both of those situations, fasting glucose and postprandial glucose. And obviously you put fasting and postprandial together, that's what drives what your A1C is. So I think that's where the liver comes into play. And then obviously, maybe we can get into it, but your beta cell and your pancreas being able to secrete insulin appropriately to help shut that liver off is probably the key piece in that postprandial hyperglycemia, which is something our lab is very interested in, those glucose spikes and how to mitigate them.
Mm-hmm. There's lots of directions I could take this. I'm actually interested in what role glucagon might play in type 2 diabetes in not shutting, like in the gluconeogenesis happening and not turning off. Is it abnormal signaling from glucagon?
Yeah, so I think one of the things that I'm not an expert in glucagon, but one of the things that I remember seeing, and I can't remember the classic glucagon researcher, and the name is escaping me right now. Maybe you'll be able to jog my memory. But when they show cross sections of the pancreas in people with type 2 diabetes or mice with insulin resistance, you see that the alpha cells and the beta cells are juxtaposed right beside each other, and the insulin released from the beta cell right beside that alpha cell is very key for inhibiting glucagon secretion. In type 2 diabetes, when you have alpha cells are there, but your beta cell mass is reduced by 70%, I think it's that signaling. You just don't get that shut off of glucagon that you normally would get in that kind of paracrine-like signaling. So to me, that's the most clear, demonstration of glucagon. It's just that we don't have the beta cells shutting off the alpha cells right there in a coordinated fashion.
Right, that makes sense. So why don't you explain why it's important to avoid postprandial hyperglycemia? Because I think that this is hard to communicate, especially in terms of prevention. That's what I struggle with. It's like talking to family members and my loved ones, just trying to explain why I don't want them eating refined carbohydrates that would spike their glucose high periodically throughout the day. But it's hard to communicate why. And I would love to know how you would answer that. We can talk about it in terms of prevention, but also in terms of type 2 diabetics or those with pre-diabetes, because postprandial hyperglycemia is really important to mitigate in these individuals to reduce adverse health risks. So yeah,
sure.
You want to take that away?
Yeah, so maybe I'll take a more molecular scientific tact, and then I'll try maybe more an analogy or a layperson summary. So I'll take both angles. So from the molecular side, we know from the classic work from Antonio Ceriello and others that the spike in glucose, the postprandial spike, seems to be impairing our endothelial function. And again, that comes down to the fact that endothelial cells, so those are the cells, the single layer of cells lining all of our blood vessels, they don't have insulin regulated glucose uptake. So whatever the bloodstream sees, those cells are going to get in terms of glucose. So when you get a big swing in glucose, through a series of very elegant in vitro studies in cultured endothelial cells, studies in mice and rats where they can manipulate glucose up and down, and then into studies in humans, both healthy and through to type 2 diabetes, that group was able to show very nicely that those swings in glucose have several detrimental effects. So the two most acute ones are you're shoving in all of this fuel into those endothelial cells, and there's no increase in ATP demand. So you're shoving in a bunch of fuel, but they don't have, they don't need it essentially, and it overwhelms the mitochondria, leading to mitochondrial superoxide production and an increase in ROS or oxidative stress, and that activates a whole bunch of signaling pathways that can impair the function of those endothelial cells. It also those swings seem to cause inflammation directly in the endothelial cells, but also in white blood cells, which have similar type of glucoregulation in terms of if you rises in the blood, those cells are going to take it up and causes inflammation. So now you have increased ROS, you have increased inflammation. Both of those work in concert to lower the bioavailability of nitric oxide, which of course is released by the endothelial cells to help blood vessels relax, as well as nitric oxide has a whole bunch of other signaling effects. But the most simple one is nitric oxide helps blood vessels relax. So you put that together, these swings are damaging the endothelial cells, activating inflammatory pathways, and then impairing the ability of our blood vessels to dilate, and that's linked with cardiovascular health and increased blood pressure in that. And again, the data from cells to animals to humans, and then we even have epidemiological data in that to show that even when people without type 2 diabetes, so these are people with pre-diabetes or impaired glucose tolerance, in free living conditions, the epidemiological data suggests that your post-meal glucose values are linked with cardiovascular events later in life. So I think you put all that together, it's a pretty solid story. Do we have perfect causative evidence that, if your mom has a high glucose spike after breakfast, that it's going to cause this damage? No, we don't have perfect, but when all of those things line up, to me, cells to animals to humans to epidemiology, it's pretty convincing. The other thing that's really cool about those glucose spikes is the work on the sort of metabolic memory that I talked about. So when you experience a spike, then you have activation of NF-kappa B and inflammatory pathways that persists for many weeks, months afterwards. And that's really cool research that kind of suggests, I don't know, one bad meal a month or something like that, where you have a huge spike, might have a memory. And again, there's solid animal and cell culture data on that. And then there's kind of the associative data that would show that. So that's, individuals that have the same A1C, let's say, but one of them has, their A1C is the same, but they have one meal a week where they have a big, weekend blowout or something like that of eating carbohydrates, and they maybe seem to have a bit higher risk, or again, suggesting that you could have the same A1C, but some person has worse outcomes because of those metabolic memory effects of the glucose spike. So that's my scientific foray into that. I suppose from a lay person, I would always explain it like that, where if you have no need for this big insurgence of glucose, of fuel, it needs to go somewhere, and your body needs to have to deal with it. So you're making your body work really hard to have to deal with this big insurgence of glucose, which comes from processed carbohydrates and food. And that's one of the, we've done a little bit of work with post-meal walking in pre-diabetes and type 2 diabetes. And that's where I think it makes sense. And you can make that make sense to someone who doesn't need to understand mitochondrial superoxide production and NF-kappa B and that, but you can say, hey, you just gave your body a bunch of easy, cheap, used fuel, and then you didn't use any of it. Go out for a little walk and use some of it, and that seems to make sense to people if you explain it that way.
Mm-hmm. And I think it's important to highlight that exercise, and when we're activating skeletal muscle activity, that's insulin independent. So it's a glucose disposal. So we're allowing ourselves to clear glucose from the blood without having to secrete insulin. So I think that's important for people to understand, and that's how exercise can be very efficacious in glycemic control. But you mentioned post-meal walks in mitigating some of the postprandial glucose excursions, but you've also done some pre-meal HIIT training and sprint interval training, I think maybe. And
Yeah.
you call them like snacks, and I forget what they're called, but something with snacks in quotations. So before a meal, do you want to explain that and how they were very short term? I think it was like 6 minutes of exercise before a meal, and that significantly lowered postprandial glucose. But yeah, explain some of that research.
Sure. Yeah. So I can't take credit for the exercise snacks moniker. That was a PhD student of mine, Dr. Monique Francois. She did that study. I think it was her master's before she came to my lab, where they did the pre-meal snacks. So 6 minutes of interval training. So 1 minute on, 1 minute off before breakfast, lunch, and dinner. And again, her hypothesis where they were going in that was to activate skeletal muscle, increase insulin sensitivity before you have your meal. And they were able to show in that paper, this is probably 10 years ago now, that that was effective for lowering postprandial glucose spikes, and more effective than if you did a one bout of exercise in the morning or in the afternoon at like a prolonged bout. We've taken that kind of one step further in our idea of exercise snacks or sprint snacks. So these are 20. The latest stuff we've done is we did some studies in the lab on a bike to try, so we can control the power output and measure things and make sure people are actually doing it. So a 20-second sprint every 1 to 4 hours. You do 3 of those a day. So it's 1 minute of total exercise, I suppose. There's a little bit of a warm up and cool down, but we've shown that that's enough to improve fitness in people that are inactive or sedentary coming into the study. So 3 20-second sprints 3 days a week was enough to improve fitness. And then now we've kind of taken that to try to be a bit more practical and combine it. So you say, okay, you can get the fitness benefits. What if you can also get the metabolic benefits? And we've done one of those breaking up prolonged sitting studies that was just published. So we had people come into the lab. We had to buy a nice big lounge chair, comfy lounge chair in the lab, because they had to sit for 9 hours in the lab. So it was a bit extreme. And then once an hour, they would do a 20-second stair climb to try to pseudo simulate what you might be able to do in an office building or something like that. And it was really cool findings in that study. We found that particularly in people with overweight or obesity, climbing 3 flights of stairs once an hour over 9 hours was able to lower their insulin levels and improve their markers of insulin sensitivity throughout the day. So we can potentially mitigate some of the detrimental effects of prolonged sitting with these little short bursts of exercise. So we're trying to take that exercise snacks approach into the real world now to see if it can improve metabolic health and fitness and even work productivity and things like that in a workplace setting. COVID has hindered us in that, because obviously getting into office towers and doing studies in the field is not possible right now. So we're kind of on pause with that work and trying to decide whether we just wait or convert it to exercise snacks in the work from home environment. So we'll have to see what happens with that line of work. But yeah, it's exciting, and we like that. The idea of exercise snacks. The reviewer on that paper wanted us to change the title, but we stuck with our guns because we wanted to get exercise snacks out there in the literature.
That's hilarious. I love it. But I love this research because it is very practical. I could tell my mom, like, every hour, go run up the stairs 3 times. Like that's a very practical thing that a lot of people can adopt. And it doesn't seem as overwhelming than like exercise for 45 minutes a day. And I think that's the whole basis for the interest into high intensity interval training, is because we can reduce the time. It removes the barrier of I don't have the time to work out. And you can get the same benefits or even better benefits. Are you of the opinion that you get more the better metabolic health outcomes by doing higher intensity interval training, even though it's less time spent exercising than continuous, like moderate intensity training?
Yeah, so my answer there is going to be a bit nuanced, so I apologize for my scientist type of answer. I think it's fairly clear that if you match the work and the time done, you get more bang for your buck out of doing interval training. So if you only had 15 minutes to exercise that day, if you went for 15 minutes of moderate intensity walking or jogging, certainly that's good, right? I'm not going to say that walking is bad for you. But if you did 15 minutes of HIIT, I think the evidence would say that you'd get more bang for your buck for HIIT. Now, if you do low volume HIIT and then you do traditional volume moderate intensity training, then it's about equal. So we've done several studies in our lab where we compare the low volume or the time efficient HIIT approach to 30 to 50 minutes of moderate intensity traditional type endurance training, and by and large in those studies they usually come out equal on most measurements. I don't think HIIT is universally better, but if you had the same amount of time, then HIIT would come out on top. And then if you look at the studies from Norway, from Ulrich Wisloff's group, a lot of the clinical populations, they're not doing time efficient HIIT. They call it aerobic interval training. That's the 4x4 minute model. It's still a 47-minute workout or something when you add the warm up and cool down. So it's certainly not time efficient, but if you did 47 minutes of their aerobic interval training or 47 minutes of steady state, their studies would suggest that then HIIT comes out on top there. So I've kind of put that all together and say it's more bang for your buck, but it's not necessarily universally better.
Right. So, but if we were under time constraint, then HIIT would obviously be the option. And
I think so, yeah.
What do you define as high intensity interval training? I don't actually know if there's like a clear definition of it.
Yeah, that's great. I mean, there was a Twitter conversation I saw the other day on critiquing that the definition of HIIT has creeped down over the years or something like that. So Marty Gabal and I have thought a lot about this and tried to put some definitions in a few of our review papers. And I think that it's fairly clear we can delineate between HIIT, high intensity interval training, and SIT, sprint interval training. They used to kind of go by the same, 10-15 years ago when we started in this, they would go by the same thing, and it depended on who was doing it. But sprint interval training is when your intervals, the on portion is all out or maximal efforts. So we originally started doing that using the repeated Wingate training model. So if anyone's ever done a Wingate test, 30 seconds all out, it's called the Wingate anaerobic test. I don't like the term anaerobic necessarily, but it hurts when you do that, right? You do one of those and you're tanked, and then you take a 4-minute rest, and we make people do another one. So we'd have to have a puke bucket beside the bike in those studies, because some people are getting sick, and then at the end of your time efficient repeated Wingate, lots of times people have to lie down with their feet up for 10 or 15 minutes before they can leave the lab. So it's not necessarily as time efficient or practical. So that's SIT, and not all SIT needs to be that extreme, but it's the efforts are all out, right? HIIT is the efforts are high intensity, but they're not all out. We kind of define that as 80 to 100% of VO2 max or heart rate max. And again, I'm not a huge, hardcore exercise intensity domain type of person. I totally get it, but in the work that we do, we're trying to translate most of this to the real world, and someone who's out walking up a hill to increase their intensity. I don't, for 1 minute, as usually the intervals that we use, I don't know if it really matters if they're at their respiratory compensation point or their critical power inflection point or whatever. The goal of that is just to get someone to get into the vigorous domain. So we use cues like RPE and the huffing and puffing type of cues for the people with type 2 diabetes to get them into what's probably the right zone. So HIIT 80 to 100% of VO2 max or heart rate max. Sit is the all out sprinting. So.
And what would the rest be for HIIT between intervals?
Yeah, and then that's where it can vary. So I think our standard broad definition, when I give a talk on this, and I usually give a definition of HIIT, it's brief bursts of vigorous exercise interspersed with periods of rest or recovery. And then my next slide is, obviously that means there's infinitely variable number of combinations that we can do. You can come up with essentially any combination of on-off exercise. So the short answer is it depends. In a lot of our HIIT work, we've used the 1 minute on, 1 minute off model. So 1 minute on, 80 to 100% of VO2 max, 1 minute off, which is just recovery, slow recovery, keep moving. How we came up with the 1 minute on, 1 minute off is not really, I don't really remember. It was, we thought it was easy to remember. We did a study that had 1 minute on and 75 seconds off. There was probably at some point we were trying to match the time, I think, actually, to the Wingate protocol. So we wanted to match the total time for the workout, which was, 18.75 minutes or something like that. So then we came up with this protocol in our first study. And then we said, hey, does it really matter if you have 75 seconds of rest or 60 seconds of rest? Probably not too much. So let's just go with something that's easy to remember. And it's a blessing and a curse in the interval training world, because obviously if you come up with a new protocol, then you've got to try to justify or rationalize to the reviewers and into yourself, why did you choose this new protocol? So we kind of get stuck in our ways of testing the same protocol over and over, because you go in to start a study and you say, well, I got to use something that's worked in the past. So for us, the 10 by 1 minute model has worked, so we use it. Other people are still studying that repeated Wingate model, 4 Wingates with 4 minutes rest, even though I think, it's powerful and it demonstrates a point that you can get aerobic adaptations with quote unquote anaerobic work, but it's not very practical. So I don't know why I wouldn't run a repeated Wingate study in my lab right now, just because of the practicality, but I can get why some people, you might get stuck into doing it because you got to do what's been shown in the past.
Yeah. And so translating this, what is the intervention usually? So I think you mentioned 10 minutes in there. Is that how long? Like 1 minute on, 1 minute off for 10 minutes?
For 20 minutes. So
for
10
20
repeats of that.
Okay.
Yeah. So, and the way we've published a few papers now in individuals with prediabetes, and we have, my wife is a behavioral scientist and an exercise psychologist. And so she has a program running in the YMCA right now, a diabetes prevention program. And it's not only HIIT, but the individuals get an option of doing HIIT. So they get introduced to HIIT, and then they can choose if they want to try it out. And the model we went with now that seems to work very well is we start. So most of these individuals aren't accustomed to exercise, they're not regular exercisers. So for that means that one, HIIT is not sprinting for them, right? HIIT is picking up the pace of their walking. Where I live in Kelowna is mountainous, so there's lots of hills. So we say find a hill or a set of stairs or something, and that is the interval training for them, or the high intensity portion. And we start with 4 intervals, 4 by 1 minute, and that for the first week, and then we move it up to 5 and 6, and then every week we kind of just add an interval on until they get to 10, and then 1 minute on, 1 minute off. Repeat that 10 times. A little bit of warm up, a little bit of cool down. It's about a 25-minute overall workout. So usually it's 3-minute warm up, 1 minute on, 1 minute off for 20 minutes, 2-minute cool down.
Cool. And that's really interesting with the behavioral aspect of it. Do these participants, like, is adherence good? Do they enjoy it? Do they think it's easy? What is the
Yeah, so
feedback?
I think it's certainly individualized. So if I walk through a few of the papers, we published a pilot study on that, which hinted that interval training may have had better adherence or equal adherence, but they got slightly better improvements in their fitness. And then we turned that and we ran a big trial with 1 year independent adherence. So the individuals spent 2 or 3 weeks in the lab, essentially learning how to do HIIT or how to do moderate intensity continuous training. And then we kind of let them loose, in the real world and ask them, stick to this 3 days a week for the next year. And in that, when we ran the big study, the big trial, there was no difference in adherence to HIIT or MIC. So I don't think that's a bad thing. I think it means that, adherence to exercise over a year for people who are inactive is hard and tends to be quite low. I mean, the studies say that 50% of people after 6 months will be not exercising anymore, right? So we interpret that to mean HIIT is an option, as well as moderate intensity continuous training is an option. They're equally good or equally bad, depends on how you want to look at it. And the take home point there is it's, sticking to exercise for a lot of people in their lives is not easy. And we probably need, I don't know about continuous, but certainly ongoing behavioral support and interventions. So that's kind of led to what I mentioned there, that in the current program, we're not forcing people to do HIIT or MICT. We let them choose, and then we're doing some cool little studies to try to see what they choose to do. And then if they do choose HIIT, do they actually then, is that better than forcing them or randomizing them to do HIIT? So those studies will take a while to do, and they're obviously a little bit messy because they're not super clean RCTs, but hopefully we'll gain some good evidence. But overall from that, I think it's clear that HIIT's not the magic bullet. It's not like, oh yeah, if you take away the barrier of time, everybody sticks to exercise. Certainly that's not the case, but it's not the opposite. It's not that HIIT is too hard for people to do. And if you have, obesity or you're unaccustomed to exercise, there's no way you can do HIIT. That's certainly not the case either. So it's somewhere in the middle, which I think is a reasonable and logical conclusion.
Yeah, no, that's very cool. I think that's very interesting research. But let's take a turn into the dietary interventions that you've worked on. So you've looked at low carb diets in type 2 diabetics, pre-diabetics. So yeah, do you want to dive into that a little bit? And maybe we'll talk about the study where you, or no, wait, I think I'm mixing up studies. Actually, I'll let you take it away, and then it'll trigger my memory of what study I want to bring up.
Yeah. So yeah. So I guess we got into this. I am not a low carb zealot, or I wasn't a low carb in the low carb community or anything. But we got into this from I'm a logical or practical person, right? So we were studying these postprandial glucose spikes, and we talked about exercise snacks, post-meal walking, and kind of it dawned upon us one day that all of these different strategies, what if people just didn't eat carbohydrates and then you wouldn't get a glucose spike, right? And it sounds kind of stupid now, but we were like, okay, well, but nutrition's not easy. If you take away one thing, you've got to add something else in, right? So if you take away carbs, you can only get protein so high, so you're going to have to add in fat. So and there's many studies, maybe not all perfect or good, but certainly the idea that high fat causes inflammation and endothelial dysfunction that we kind of talked about with the glucose spikes. There's a whole bunch of data to suggest that high fat diets and high fat meals are bad for that as well. So we said, well, the first study we need to do here is to do low carb, high fat diet and look at, we think it's going to improve glucose control. That's kind of a no-brainer, but we got to see if it affects blood vessel function and inflammation in people with type 2 diabetes. Because obviously if you're, fixing the glucose spikes, but causing rampant endothelial dysfunction, it's probably not going to be a good therapy. So we ran a series of studies that were short-term on purpose because we wanted to control everything that the person was eating but we also didn't want them to lose weight. And we knew from going to the literature that if we put someone on a low carb, high fat diet, they're most likely going to lose weight. And then that would confound any of our inflammation markers, right? Because if someone loses, 4 or 5 kilos or, 10, 15 pounds over a long term and their inflammation goes down, it might not be because the glucose or the low carb diet, it might be just because they lost weight. So we said, we got to keep this tight and short. So we did these 4 or 5 day low carb, high fat diet studies. We also said, hey, a lot of the stuff that high fat meals cause endothelial dysfunction or inflammation are unrealistic high fat meals, a 950 calorie whipped cream milkshake or something like that, right? And that's not what people would eat for a meal. So we used, whole food, healthy, real food, low carb, high fat. And what we saw in those studies is, not surprisingly, glucose was, much improved over the 4 days compared to what we consider gold standard low fat diet. So like brown rice and chicken and broccoli, stir fries, and things like that.
So it's compared to like an actual whole foods based higher carb.
So yeah, so both, it was low fat, high carb, whole food, gold standard versus low carb, high fat, whole food, gold standard, if you want to consider it that, avocados and olive oil and that. So not butter and fat bombs or something like that, right? And what we saw is glucose was not surprisingly better on the low carb, high fat, but inflammation tended to go down and blood vessel function was improved. So the two kind of big negative things that we were looking for were also improved. So that kind of got us excited to say, hey, let's continue on this, because the kind of negative side effects that we might have, or the off-target effects, were in the positive direction. So that got us started on the low carb work. We haven't done a ton of low carb work in individuals with prediabetes yet, but I think the pathophysiology of type 2 diabetes and prediabetes is the similar same disease, or almost the same condition from my perspective. And my practical pragmatic brain says, you have impaired glucose tolerance. That could also be worded as impaired carbohydrate tolerance. And if you have lactose intolerance, you remove lactose. If you have gluten intolerance, you remove glucose. If you have carbohydrate intolerance, maybe you should remove carbohydrates. So that makes sense, as long as the side effects or the consequences of doing that aren't detrimental. And in the case of low carb, high fat diets for people with type 2 diabetes in particular, the side effects or the consequences of replacing the carbs with fat certainly doesn't seem to be bad. If anything, it's good.
Right. Yeah. No, it makes a lot of sense. I like the way you put that too. I think that's very clear and cut. In one of your studies, you showed that if you just replace breakfast with a low carb meal, it improved 24-hour area under the curve glucose control and glycemic variability throughout the day. And which that is in itself just a very practical thing that people can do. They don't even have to change lunch and dinner, just eat a low carb breakfast. And I actually reached out to you when this study was published because I was confused, because I thought that our insulin sensitivity is highest in the morning, but you pointed out to me that it's actually the reverse in type 2 diabetics, which I don't actually fully understand. I don't know if you could give an explanation for that, but and also if that means that we should switch that for healthy individuals, and maybe we should be front loading our carbohydrates and back loading higher fat and protein and removing carbohydrates later in the day. If you want to give your opinion on that.
Sure. Yeah, those are great questions. So, in our lab, we like running these, we talked about the sprint snack stuff. We like running cool, novel, practical studies. So, so the low carb breakfast study came about from, I mentioned in my PhD, using continuous glucose monitoring. What we almost always see, 80% of the time, the biggest spike of the day on someone with type 2 diabetes on their CGM curve is breakfast. So I used to just think that was because standard Western breakfast foods are high in carbohydrates, right? You have toast, you have juice, you have fruit, you have oatmeal. But when you dig into the literature and the physiology there, we've known for many years that individuals with type 2 diabetes and probably insulin resistance too are most insulin resistant in the morning And that would feed into that being the largest spike, regardless of what you ate. And there's Evelyn Van Cotter is published a ton of work on this in the late 90s. There's a review article from her that summarizes all her work, and it's brilliant and amazing, like hardcore metabolism studies, right, where they have people in and they're infusing glucose throughout the night and the day and being able to clamp glucose and measure sensitivity to insulin and measure hepatic glucose production. Just amazing metabolic studies that demonstrated this. And this was before circadian rhythms and diurnal things became, cool and popular, I suppose, in the literature. And they showed that the healthy insulin sensitive individual their insulin sensitivity would be highest in the morning and then kind of deteriorates throughout the day. But in type 2 diabetes, it was reversed. I think it comes down to the dawn phenomenon, the fact that you have higher glucagon to insulin ratio and your liver glucose output is high. They've also linked it to free fatty acids. So if you have high delivery of free fatty acids to the liver that turns on gluconeogenesis. So I think that's probably the mechanism why someone with type 2 diabetes has that opposite response. But so back to the low carb study. So we said, okay, well, the physiology seems to make sense that they shouldn't eat carbohydrates in the morning. We always see this huge glucose spike. And I had two students, Monique Francois, I mentioned before, and Courtney Chang, who was a master's student at the time. And we said, let's just run this, give a low carb breakfast. And there's lots of low carb options that people that are normal breakfast foods, right? An omelet would be one. So we just ran this, kind of fun little study. I think it was 24 or 25 patients with type 2 diabetes. And one day in a randomized order, they had the omelet breakfast, and one day they had the oatmeal and berries breakfast, and then we gave them the exact same lunch and dinner. And lo and behold, again, not surprisingly, when you don't eat carbohydrates for breakfast, there's no glucose spike. And then lunch and dinner were the exact same spike. So when you put it all together, you take away the biggest spike of the day. So we were excited. It's a cool little fun study, and we were actually able to turn that data into, we're running an RCT right now over 3 months. So see if the approach is enough to improve A1C and glucose control, as well as we found some cool things in that study. It wasn't designed for this, but when people had the low carb breakfast, they tended to be less hungry later in the day, and they had less desire for sugary sweet foods, which again, I think, people tend to make poorer food choices maybe after dinner. If we're changing some of that based on having the low carb breakfast. So we'll see that that RCT got severely impacted by COVID, as you can imagine. So we have completely adapted it into a virtual clinical trial. So we don't have to have any interaction with participants in the lab, because we're not able to bring in high risk populations right now. So we just launched, I think we've randomized our first 10 out of 80 people this week to do a virtual low carb breakfast trial. So that's exciting. And there's been actually a couple of other papers come out recently on that I think are generally in support of the idea. Nothing's been powered enough yet to see a reduction in A1C. The effect is not huge, right? It's not the same as eating low carb for every meal. But yeah, we think it's potentially a sustainable option for some people if you don't want to go full low carb all the time, or on a day when you're going to have, I've got a event tonight and it's going to be really hard to stick to my low carb diet. Well, make sure I keep that breakfast spike out of the equation by having a low carb breakfast today. So
yeah, very cool. I'm excited to see the results of this study. Will the participants be wearing continuous glucose monitors?
Yes, yeah, we'll have them on wearing Freestyle Libre, so I guess flash glucose monitoring for 14 days at the start and the end of the study as well.
Cool.
So it'll be interesting. It's actually our first time using the Libre in a trial. I've always been stuck to using the iPro 2 in trials, because it's a little bit better from a scientific perspective to have a blinded device that's continuous. So, but we've got the Freestyle Libre Pro, which is a blinded version that you can use for research. So we had to, that was one of the adaptations. We had to purchase, instead of having those CGMs or flash glucose monitors, you put it on and then you just scan it in the lab usually, and then the participant can go off for 14 days and then mail the sensor back to you. But because we can't see them, so now we've had to buy a sensor for every single participant, mail it to them so that they can activate their sensor and then mail it back to us. So,
wow.
So that's been one of our challenges in that study, and getting it going and trying to make sure we have enough money to complete the study with all the adaptations.
And how do you feel about people using CGMs for preventative measures and adapting their lifestyle behaviors around maybe the results that they see from their CGM?
Yeah, I think it's an interesting area, and certainly I've tried lots of CGM, playing around, and certainly for someone who's interested in that, it can actually be a bit addictive and take up a lot of your time. But I think it can be certainly useful. One thing I will say, I mean, we've been talking about postprandial glucose spikes and that. I don't know, or I'm not convinced that spiking your glucose from 5 millimoles to 7 millimoles for half an hour is actually bad, right? And not, I haven't worn a CGM for a while now, right? But I can wear a CGM and you kind of play around and like, okay, let's try a higher carb meal. I got up to 8.6. This is bad, but my glucose is only at 8.6 for 20 or 30 minutes, and then it's back down to normal. So I don't think we have the evidence to suggest that 5 to 8 or whatever is killing me or damaging my endothelial cells. So I think I like it. I think it's cool, but I don't know if every single person has to have a straight line glucose all day, every day. I don't know. I don't think we have the evidence that that's the surefire healthiest way to live. And obviously nutrition is challenging, right? So in order to get a straight line glucose all day, you've got to eat different types and quality of food than what you eat when you have glucose spikes. So maybe it's not the stable glucose that is making you less hungry. It's because you're eating higher protein foods or more satiating foods. So it's a bit I think it's a bit challenging to say everyone should wear a CGM and be flatline all day. I'm not sure if we know that for sure, but yeah, I don't know. What's your opinion on that?
I don't know. I've never trialed with a CGM. I do have just the Freestyle Abbott monitor that I just do single pricks, and I do just test products here and there or different meals just to see my glucose response. But I would love to experiment with a CGM. But I think it is really important to point out that these glucose excursions, they are normal, like it's a part of normal physiology, but how would you define good glycemic control? Like what are we trying to achieve?
Yeah, so I think that depends on if you have diabetes versus, if you're normal glycemic, healthy, lean, young, 35-year-old or something like that. I think those are probably different.
Okay, from the point of view of like a preventative point of view.
Yeah. So from a preventative, I think, again, we don't have CGM curve data to say you should be, in this range or anything like that. I don't think. But certainly, keeping your A1C in and around the 5% range is probably all you might need to worry about in that respect. And maybe we'll get into this, but it does. I'm cognizant that if you are following a very low carb or ketogenic diet to try to keep your glucose perfectly stable and never have a glucose spike, if you're young and healthy, the natural, the appropriate adaptation of your body in that respect is to become insulin resistant and glucose intolerant, right? And that's normal. That's what your body should do. If you feed it all fat and no carbohydrates, why would your metabolic pathways and gene expression in your muscle and your liver and your pancreas, why would it be geared towards dealing with carbohydrates? But then if you reintroduce carbohydrates in that, healthy body that's adapted appropriately to become intolerant to carbohydrates, that could cause some problems. And I think that's where we simply don't know. And but we do know from, the generalization is that people do have trouble sticking to a restrictive diet forever and ever, right? So if maybe you do it for 2 years and that's great, and then you slowly start to, reintroduce carbs, or start to have these, less strict. Your body now has, if it's adapted appropriately, it's become intolerant to carbohydrates, and then you reintroduce them back. And we've done a little bit of another fun little study where we did that over the course of just 1 week. And we saw that when you follow a very low carb or keto diet for 1 week, and then you do a oral glucose tolerance test before and after, you become a little bit intolerant to the glucose or the carbs after 7 days. And again, that's normal, right? That's what your body should do if you're healthy and adaptive. But it seemed to cause some markers of blood vessel damage, so to go up afterwards. And this is in young, healthy people. So again, that study was, a fun little study. It was an undergrad student's project. And it's not the definitive answer to that question, but, it makes a little bit of sense to me that physiologically we probably shouldn't be doing, cycling on keto and then going on a binge day or something like that. And again, I think when I remember talking with Jeff Volek about this too, and some folks in his lab, and they don't have hard data on this, but they would say you shouldn't bounce in and out of ketosis and play around with it. It's probably not the healthiest way to go.
Yeah, it is interesting because there's lots of different views, because some people think that cycling in and out would aid in metabolic flexibility. Then we're not down regulating these glycolytic pathways, but we're still keeping the ketolytic pathways open as well. And that could be a sign of metabolic flexibility, which we want to be. We're designed to be metabolically flexible. If we lose that metabolic flexibility, that's when problems arise, and that's associated with all these chronic diseases. So I'm kind of confused myself, because I am a proponent of low carbohydrate diets, but then I don't want to be so physiologically insulin resistant to the point where I can't handle carbs. But I think Ben Bickman talks a lot about how it takes about 3 days to return to a normal insulin sensitivity. And maybe that once you return, that baseline sensitivity might be improved compared to before the low carb diet. There's a lot of questions that need to be answered, because personally, it influences my own lifestyle. How do these findings influence the way you eat? And I think it's important to also note that in the study that that was designed with the 7 days of keto plus an oral glucose tolerance test, it's just a glucose load. This isn't eating a sweet potato or a fibrous fruit or something. This is full on glucose. So it's going to cause an excursion that's probably greater than something that's eaten in a whole food form. So I wonder if we would have such a dramatic response, and how we could titrate carbs back into our diet after following a long-term ketogenic diet. And if you think that this is a problem, like a long-term ketogenic diet, if you see this as kind of being something to be weary about and when adopting a ketogenic diet. Sorry, I threw so many questions at you, but it's very interesting.
No, I mean, so first of all, you're touching on metabolic flexibility, I think is a great point. And I think if you are lean and insulin sensitive and have low insulin, or you don't have hyperinsulinemia to begin with, to me, it doesn't make that much sense to go on a ketogenic diet for general health reasons. Obviously, there's many reasons. If going on a ketogenic diet makes you feel better, or have more focus, or sleep better, or helps your acne, or whatever other thing it might be, then certainly maybe it's an approach. But if you're doing it for the hope of long-term health, but you're lean and insulin sensitive and don't have hyperinsulinemia, I'm not convinced it's the way to go, because as you said, we know that you're making yourself metabolically inflexible. You're making yourself a fat and ketone burner, and you're not good at burning carbohydrates. There's not enough studies to say 3 days to come back to insulin sensitivity. And again, those studies would be really hard to do, right? But I don't think we know if you've been following a ketogenic diet for 1 month, 6 months, 8 months, 80 months, how long it would take you or whether you would ever come back. So I think that to me, that my interpretation. So I've been on a ketogenic diet. I think I was probably on a ketogenic diet for 8 or 9 months, about 3-4 years ago. But when we had the findings from that study, as well as just, thinking this through and thinking about metabolic flexibility, I do an OGTT in the lab probably every 1 or 2 years, because a new student will need to practice putting the IV catheter in an arm or something, and I have good veins for that. So, and I noticed, again, anecdotally, that my glucose tolerance wasn't as good as it used to be when I would be following that ketogenic diet, which made sense. So I don't follow a keto diet anymore. It would be on the low carb range. Again, I don't track anything, but I probably eat 100 to 150 grams of carbohydrates a day. I feel better with that. I know that if I eat some carbohydrates, my workouts and my tennis game I feel like I have more energy. So, and I feel like that's the balance for me to kind of say, hey, I cut out junk like added sugars and processed carbs, and that automatically gets your carbohydrate content down, right? And eating whole foods, but I don't really track and try to stay in ketosis, and that's primarily because I think I want to maintain some metabolic flexibility. I think if you have hyperinsulinemia to begin with, then it becomes a bit more complicated, because by going very low carb, you're going to then correct your hyperinsulinemia, which then makes you more, because that hyperinsulinemia is driving insulin resistance, right? So then you remove the hyperinsulinemia induced insulin resistance, but you maybe add on some high fat induced insulin resistance, and maybe it balances out somewhere. So in that situation of someone who's hyperinsulinemic, pre-diabetic, type 2 diabetes, then it becomes a bit more convincing to me to do that. So I think that was maybe your first question. I can't remember the other ones after that. Sorry.
No, I think that answer kind of covered everything I was ranting on about. Do you think that type 2 diabetics following low carb ketogenic diets, would they, even after they've put their diabetes in remission, would they have to stick to a low carb diet or a ketogenic diet for life? Or do you think that they could titrate carbs back in once they kind of reverse some of the insulin resistance?
Yeah, that's a great question. One we're trying to work on some grants to study. I don't think we know the answer to that yet, right? So I think the direct trial with very low calorie, the total diet replacement, the data there is fairly convincing that the pathophysiology, at least for some individuals, is reversed, right? So that they now regain beta cell function. And the diet data in that study is not very good. So we don't really know exactly what they're eating, right? In the trials, they say, they follow the eat well guidelines and it was adjusted so that they don't regain weight. So I don't think we really know what they're eating, but presumably they're eating some carbohydrates in that, but probably still a quite low energy diet, even while they're in remission. But if they're eating, to me, if you're eating some amount of carbohydrates and not getting back into diabetes ranges in your glucose control, then you're in true remission. I think the keto studies or the VERTA trial, those people to me depends on how you want to interpret reversal remission. But if you're still on a ketogenic diet, you're still technically following a therapy, I suppose, right? So, and the VERTA results, not to take anything away from them, but they haven't shown true pathophysiological reversal, right? They haven't shown that individual's beta cell function is back towards normal. So we don't know that yet. So we are very interested in this right now on whether individuals with type 2 diabetes who are following a low carb or keto diet actually have recuperation of beta cell function. Because to me, that would be what needs to be shown to say your disease is reversed or in remission. And I don't have any of that data. Again, it was a study that got halted during COVID. So hopefully we can resurrect that and try to explore that. But I do think, so from my interpretation of the literature and our own experience, as well as pathophysiology, you probably can't go on a keto diet, take away your medications, get your A1C normal, and then just go back to eating whatever you want. Certainly there's, all the pathophysiology is not going to be reversed, as well as we know that type 2 diabetes is, there's genetic components and age and all that, which is usually not on someone's side if they have type 2 diabetes. So I think there's, probably some personalized level of carbohydrate tolerance within the overall matrix of high quality diet that can be there. So we have follow-up going on from one of our studies where we're trying to look at the sustainability of remission, or at least withdrawal of medications. And that's kind of how we're doing it. It's an exploratory secondary analysis of the trial in the follow-up phase to see, and that's what we kind of go on as an individualized carbohydrate tolerance. But again, it's not driven by carbohydrate metabolism data. It's mostly driven by weight regain, right? So if someone starts to regain the weight that they lost, then we move in and try to lower the carbohydrates down.
Interesting. Yeah, I've always wondered if like the Virta data and like ketogenic diets were more of a management than a treatment. And I wonder what they would say about that.
Yeah, and I mean, I think the way that you word it, if you want to be on pro Virta or pro keto, is, well, it's a lifestyle, not a diet. So you're following that lifestyle now. And I agree with that approach, but obviously that's a little bit of a cop-out approach too, to say, well, it's your lifestyle, because not everyone can probably stick to that forever. So I think it's an area of it's very interesting to see, and I think beta cell function is the key to look at there. Is the disease actually gone or gotten better, or are you just masking the underlying pathophysiology by not eating carbohydrates? But I still think that even if you're just masking the underlying physiology, again, back to what we chatted before, if your glucose is now stable, as long as the side effects of that diet don't have these off-target effects, which it doesn't look like for most people that it does, then it's probably a good management or treatment strategy.
Yeah, I mean, I'd rather manage my disease through diet than through pharmaceuticals that could be causing other problems. So totally. This is not to take away any of the success from Virta, because I think that they're doing amazing work. But so many more questions that I could ask you, but I also want to respect your time. I would like to transition quickly into exogenous ketones, because recently you've taken this direction with the ketone monoester in glucose control. So I think that is fascinating. And maybe like what's your opinion on ketones? Are you a proponent of ketosis? Like, you say you don't follow a ketogenic diet anymore, but maybe do you use intermittent fasting to induce ketosis? Do you take exogenous ketones? And I know this isn't supposed to be about you, but I think it's interesting when researchers, like what they learn from their research and what they implement themselves, because that kind of adds to the power of their research, in my opinion. But what have you learned from using the monoester in your research?
Yeah, so we got interested in the ketone monoester kind of, again, a lot of times in our lab by accident. We were doing a study on ketone supplements and exercise performance, and we couldn't get the monoester. So we bought a salt off of Amazon and did the performance study. And I'm not really a performance researcher, so it was kind of, an undergrad project, interesting. But we saw it consistently would lower glucose in all the participants. And these are healthy young guys. And this, I was a bit perplexed by this. I didn't know all the metabolic pathways and the signaling effects of ketones. So we kind of dug into this a little bit and went back to the literature of ketone infusion studies, lowering glucose and that. And then we also studied inflammation at the cellular level. And there's the studies coming out from Dixit's laboratory showing, inhibition of the NLRP3 inflammasome and anti-inflammatory signaling effects. So I said, hey, this is kind of fits in with all the stuff we do: glucose lowering, anti-inflammatory intervention. So that's what kind of got us into it. I happened to luck out at a conference where I met David Holdsworth, who was working in Kieran Clark's lab at the time. We sat together at a table at a banquet or something like that, and started chatting. And then he connected me with Kieran, and that led to us getting access to the ketone monoester for the next study. So it's kind of a cool science, typical science story where everyone kind of meets each other and knows. So then we got the ketone monoester to truly test out this glucose lowering effect, and shown in several studies now that raising BHB through taking the supplement lowers glucose and then improves glucose tolerance, or I guess glucose remains lower throughout a glucose excursion. So that's how we got into that. I think I view ketone supplements as a very intriguing tool to be able to manipulate ketosis and BHB in particular in our case. So using the BHB monoester, a way to manipulate BHB in humans without having to infuse it and without having to go on a ketogenic diet. So I still view it a little bit as a research tool. I don't know if it's a treatment or therapy that's proven yet. We're running an RCT in type 2 diabetes patients as soon as, again, COVID will allow us to do that, to see if it has these effects. Because I think from the basic science, it could be a very good win-win-win. We have glucose lowering, anti-inflammatory. We've shown blood pressure lowering and some endothelial effects. So it could be a supplement that has these effects, but it's too early. I've obviously taken exogenous ketones before, but I don't regularly take them. Part of that is probably the cost, maybe a little bit. And in our case, the taste, it's not the most pleasant tasting thing to be having all the time. I don't think I've, in my placebo effect anecdotal experience, noticed all that difference. If I'm fasted and I take a ketone supplement, I don't get a boost of energy, or I wish I did. I don't get laser focus or anything like that you hear. So for me, it just doesn't seem to do that much to me in particular. So it will lower my glucose, but I don't really need to lower my glucose. So I don't take ketone supplements myself. I don't think I would advise people at this stage to say, hey, if you have obesity or diabetes, go out there and take them. I don't think that the data is there yet. Again, for me, it's still at the very intriguing research tool, and we need some more data. And your other question related to being in ketosis. So I'll track it sometimes just because we have the monitors and see, but I don't, religiously practice intermittent fasting or anything like that. If I'm probably in ketosis, it's more by accident because I'm too busy. So I usually exercise fasted in the morning, and I have a lower carb breakfast. And then I usually or often skip lunch. I have a black coffee or several coffees throughout the day because I often don't have time and I'm not that hungry. So if you add that all up, I can be in ketosis at dinner time, but it's not really by purposeful practice, I think. So
how important do you think it is to go into periods of ketosis, though? Because we talked about metabolic flexibility, and it's funny because we talked about it in the context of adding in carbs for metabolic flexibility, but the majority of the population would need to remove carbs to improve their metabolic flexibility. So do you think these periodic ketosis is really important to overall health and preventing metabolic inflexibility?
Yeah, so I'm getting more and more convinced or intrigued by it. I think when you go into endogenous ketosis, though, I don't know whether it is the period of prolonged low insulin, the increase in lipolysis and fat oxidation, and or the increase in ketones, which is the magic about that, right? So I don't know if which one it would be or the combination. My gut tells me from being a physiology and metabolism researcher that usually it's not just one thing. So maybe it's all of those things, the period of low insulin, activating PPAR delta and that through, because you have the increase in lipolysis and fat oxidation, ketones happen to also go up, and they probably have some signaling effects, but it's probably all three. But maybe ketones are just along for the ride. Maybe the increase in ketones is just a symptom of all the other things that are going on, but I'm not sure about that. So.
I think I like to view ketosis, if we find out that ketones are doing nothing, it's just a good marker to indicate that insulin is low and we're upregulating our fatty acid metabolism. So I think it's a good marker of metabolic flexibility, in my opinion.
Totally.
But I'm not sure of how often we should be going in and out of ketosis, and what I don't know where we want to sit on the spectrum of metabolic flexibility. But I think it's a very interesting conversation, and I'm excited to see this research continue, and it's exploding right now. Everyone's interested in ketogenic diets, and every day there seems to be a new paper published, which is really cool.
Yeah, totally.
So what's next for you? What's exciting? And we can wrap it up and let people know where they can find you. And yeah.
Sure. Yeah. So I mentioned we've got the clinical trial of using ketone monoesters in people with type 2 diabetes. So we're excited about that. It took a few goes to get that trial funded. And again, as you just mentioned, people are getting interested in it. This is a good sign too, that you can actually get some ketogenic or ketosis research funded by mainstream, health research foundations now. So that's exciting. And again, not just the glucose lowering, but I think the other potential effects of ketosis. So we're excited about that. And then in the type 2 diabetes remission space, and really, we didn't talk about this too much, but pushing that towards implementation and translation. So we have what we think is an innovative model of pharmacists working with physicians and registered dietitians in kind of an interdisciplinary care team to deal with the complexity of managing medication and insulin reductions when someone's on a low carbohydrate diet, and then transitioning into something that's long-term sustainable, that an individual can follow with the goal of remission. And I guess I would say, if from that big picture perspective, it's obviously not just my research, but the work of others like Verda and the direct trial. I think if every type 2 diabetes patient gets presented with the option of a nutritional approach to remission, that would be my dream come true. So, you get diagnosed with diabetes, and instead of saying, hey, this is a chronic progressive disease, you're going to be on medication for the rest of your life and likely have to go on insulin, that the doctor would say, there's 3 different approaches that you can use to get your disease into remission. You can go on a total dietary replacement. You can go on a low carb ketogenic diet. You can go on a lower carbohydrate diet. Here's how we're going to support you, and you can manage your disease without having to go on medications, and you might even be able to get your disease to go away or be in remission. And I think that would be amazing, give hope for patients, change the way we treat the disease, and really demonstrate the power of these nutritional interventions.
Yeah, it would be very empowering for a patient to receive information like that, instead of being told that they have to manage a disease for life. If they could do something about it and improve their outcomes, I think it could be very empowering to take your health into your own hands. But unfortunately, a lot of type 2 diabetics aren't given the option. So I agree with that vision. I'm here for it, and I hope that I align strongly with that as well. So where can people find you online?
Yeah, I'm on Twitter. I'm not as active as some others, but I'm on there. It's at Dr. John Little, JONLITTLE. My lab has a website which is reasonably well kept up to date now, and that is we're Exercise Metabolism and Inflammation Laboratory, so emil.ok.ubc.ca. And you could find me on obviously the UBC website and send me an email. I'm usually reasonably good at getting back to individuals, as long as you don't ask me for medical advice, which I obviously can't give out. But if you're interested in our research or our studies, I'm very happy to provide PDFs of studies or things like that if you don't have access to them.
Awesome. Well, thank you so much. I can't thank you enough for having this discussion with me today.